Syzygy, episode 27. Emily's on a mountaintop in New Zealand. Welcome back for another edition of the Syzygy podcast. Chris Stewart here, and I'm all alone this time. It's really weird. I'm in Emily's office here at the University of York, but Emily's not. She's down in New Zealand for the Christmas and New Year break, doing some observing on the top of a mountain somewhere. So I thought it'd be fun to try to get her on the phone and see how it's all been going. Hey, let's see if anyone's home.
Hello.
Emily, Chris here. How you doing?
Hi, I'm good.
Good. Where are you?
Well, I am all the way over in New Zealand.
In New Zealand. So you've escaped the northern winter and you've gone to the southern sun. How is it down there? Be nice. Don't make it too good.
Well, it has been pretty fantastic, to be honest.
Yeah. Is it warm?
It's good to get that second summer. It has been very warm. Yes, it's lovely.
Because I'm here in Yorkshire, and it's cold and it's wet and it's not even snowy. We don't even get the benefits of the snow. There was supposed to be a big snowstorm come through the other day, and it was just freezing rain and slush instead. So, yeah, I don't want to know, frankly. Have you been on a beach?
Well, not quite. I've been up a mountain.
Oh, okay. Well, I don't feel so bad then. So you've been up a mountain. Are you actually doing astronomy
I'm
things?
doing real live astronomy things right now.
How's it been going?
Well, actually, here's where you might not be so jealous of. We've had a little bit of bad weather over the last few nights. So I'm working on the telescope down here, and we are, of course, completely in the hands of the clouds. And unfortunately, they have been a little bit unkind over the last week or so.
This is the problem with ground-based astronomy, right? Is that you are at the mercy of the weather. If you were using something that was in orbit, you'd be all right. But,
yes, exactly.
But no.
So actually, on some of these cloudy nights, you might wonder, what do astronomers do when there's too many clouds to go and look at the stars?
Yeah, what do you do?
We've been playing with test data, of course.
Right. So you're not just sitting around playing cards. You've actually got something to do.
No, we've got some work to be cracking on with. So actually, it's been quite exciting this week. TESS data release came out, bang on a week ago now. So we've been trawling through the gigabytes and gigabytes of data and finding new and exciting things in it.
Fantastic. This is the show favorite. I'm actually looking at your cardboard model on the desk here in front of me here in your office. This is the Transiting Exoplanet. Hang on, remind me. Transiting Exoplanet Survey Satellite. I'll get it right.
Survey Satellite. Well done.
First sight one day. And it went up a couple of months ago, and it's now sent back its first lot of real, actual, honest-to-goodness data, and looking good.
Yeah, it's brilliant, actually. I'm really quite pleased with the quality, because there's two kind of ways. So because I don't look at exoplanets myself, I'm looking at variable stars and looking for the pulsations in those stars. And so our group that look at variable stars actually have our own way of treating the data that comes off the satellite. It's called a pipeline. Basically, you put data coming off satellite in one end, and then you get nice kind of reduced data that's ready to work with out the other end. And so there is a test pipeline. There's a very general thing that NASA do to the data to make it usable. But what we really are going to be using going forward is going to be the pipeline from the astroseismic team. So this is the pulsations team. And that pipeline's not quite ready yet. So we were just looking at kind of the raw NASA data, but the NASA data are just beautiful, really.
Remind me again, you're able to do this because TESS, even though it's in the name, exoplanet's in the name, it's looking at a whole pile of stars and looking to see whether or not they're varying in some way in order to see, on the one hand, if they can detect a planet going across in front of that star so that they can see whether or not there's an exoplanet happening there. But that's the perfect environment for what you do, which is looking at stars which are variable anyway, right?
Exactly, yeah. And there's lots of different fields that actually use this kind of data. It's basically just point at a bit of the sky and stare for about a month, and then look to see what changes. And there are huge numbers of objects in the universe that change on these kind of timescales.
So was that built into TESS's mission from the start, or was that something that someone kind of went, when you're doing this other thing with the exoplanet stuff, we could use that. Could you share?
Actually, it's been built in from the start, especially the astroseismic groups. We've been involved with target selection for tests. We've been helping out to get the maximum amount of science that the telescope can get out. And this is because we have such a really strong legacy with the Kepler Space Telescope.
Right,
So
right.
just like Kepler found thousands and thousands of exoplanets, we did a lot of really interesting things with variable stars as well. And that also helped out. There's some really nice synergies between exoplanet work and variable star work, where if you can characterize the star that you're looking at very well, then you get more information about what the planet is like too.
So you're trawling through this first bunch of data that's come out of TESS, but as you said, you're having to kind of look at it raw because it hasn't been through its pipeline, its filter yet. Is that hard to do? Like, are you having to kind of make this up on the run?
Actually, no, it's very easy. NASA are great at making data in formats that are very, very easy to use. So anyone can actually go and look at the test data if they want to. It's on a database called MAST. And its Hubble data is on the same database. You can search for a target, see what kind of observations there are, and just download them. There's lots of tutorials and helps to how to look at the data because they're kind of in special formats. But as time goes on, then these are going to be more and more accessible through MAST, where you can even just click on your object and click on the data, and you'll be able to see live in the window what the data are showing you, what it looks like.
So really keen listeners at home could go and have a look at this stuff and start doing their own research if they were that keen.
Exactly, yeah. That's the beauty of having open access data. It's really for everybody.
That's very cool. I like that. Right. So you said that that's what you've been doing because the weather hasn't been so kind. What's been going on?
Yeah, well, early summer here in the Southern Hemisphere is always a bit dodgy when it comes to observing. We're not quite at the stable part of the summer yet. The temperatures haven't quite stabilized. So and we're very, very short nights as well. So we're only observing for between 5 and 6 hours
Yes,
every night.
of course, because you're in the summer. I mean, I'm used to being here in the cold depths of winter in the Northern Hemisphere where the days are about, 15 minutes long as far as I can tell. But you've got these really long lights. But of course, you're down the other side of the world and the nights are quite short, which is not what you want when you're an astronomer.
No, no, but it does make observing rather pleasant because you're only working for a few hours and you can enjoy a little bit of the daytime as well.
Yeah, when it's all working, when the clouds are behaving,
When
when the
it's all
weather's on
working.
your side. So before we get into that in a bit more depth, tell us a little bit about where you are. You said you're up a mountain.
I am,
Where
yeah.
are you?
So I'm in the middle of the South Island of New Zealand. The observatory is the University of Canterbury's Mount John Observatory. And this is a facility which is run, it's got about 4 working research telescopes on site. And we are sitting on this kind of little knob, which is just in the middle. It's surrounded by very, very tall mountains in a basin. And we're at about 1,000 meters, and then you just look out and you get a panoramic 360-degree view of mountains from 2 to 3,000 meters all around you.
I'm imagining something which is a little bit Lord of the Rings-ish.
Definitely. In fact,
Lord of the Rings if they had
yeah,
telescopes.
well, actually, quite a lot of Lord of the Rings was filmed in this part of the world as
Really?
well.
I'm trying really
Yeah, I think
hard not
lots
to
of
be jealous right now, Emily, and that's not working.
No, it is gorgeous. It is a really, really special place. So we're above the glacial lake of Tekapo, and so it's got this beautiful sort of turquoise water from the glacial feeds. There's a little township at the bottom of the hill that provides all the sort of everyday things that we might need. So it's really just a beautiful location and very well suited to have an observatory here.
It sounds really hard. Yeah. I can remember those glacial lakes. I mean, maybe not that particular one, but visiting New Zealand a few years ago. And the colours are amazing. Like these
Yeah,
bright,
they're
bright blue turquoise. It looks surreal.
almost unnatural.
Yeah,
Yeah, yeah,
yeah,
they're
yeah.
brilliant. And then you get the snow-capped mountains just behind them. It's just stunning.
Yeah, amazing. Can you take some photos and send them to us? We'll put them up.
Oh, of course,
Yeah.
yes, yeah, yeah.
Yeah,
We'll
just
put
to
them up.
just to
Yeah.
complete the picture so that I can be weeping into my beer in a couple of nights' time. So yeah, you're in this amazing place. You're up on top of a hill, trying to observe. What are you trying to do? What's your project while you're down there?
So we're doing kind of a combination of things at the moment. So Tess is still observing,
Yep.
and we're quite interested in doing some simultaneous work. So we're looking at what targets is Tess looking at right now,
Yeah.
and from space, and we're doing some work where we are looking at those same targets from the ground, and we're doing that in two different techniques, two different instruments. And we're going to then, when the data comes from down from TESS in a couple of months' time, we'll be able to directly compare what results we have from the ground to the results from TESS. And there are some really useful things you can do with that information in terms of testing, as well as get new bits out of the data as well.
Yeah, is that sort of a calibration type thing for TESS, is to make sure that everything's going all right, or are you looking for sort of complementary data?
It's a bit of both, actually. Yeah, so you can do things like you find the same thing from the ground in space. That's always a great check. But you can also add to the test data to add the different information. So as we said, TESS is monitoring the brightness of stars. One of the instruments that we've been using down here is a spectrograph, which is looking at breaking up the starlight into all its constituent colors. And by looking at all those individual colors, you can actually draw out some information about the pulsations that you wouldn't necessarily get from the space satellite.
So how's all that been going then? You did mention that the weather hasn't been particularly cooperative. So have you got some work done, or have you been sitting around a lot waiting?
Yeah, well, we haven't had the best of luck this run actually. So we've had about an 8-night run. This is night 8. So we're just finishing up now. Had the my instrument on for 5 nights of that run. So this is the spectrograph where we're looking at the breaking up of the light. And it's probably been one of the worst runs that I've had in that sense, because I almost got 100% cloud.
Ugh.
Yeah, I think I managed to get maybe 6 science frames that I can use over 5 nights.
What do you mean science
in a
frames?
typical,
What's a science frame?
so these are stars, so frames of the star itself, rather than just your background calibrations and so on. And on a normal run of those 5 nights, I'd be getting 50, 60 minimum, maybe
So
more.
6 is not good.
No,
No.
no.
Right. This is the reality of being an astronomer, right? Is that you're at the whim of the elements, and sometimes it just doesn't go your way. I mean, I guess the same is true to different degrees in all kinds of experimental science, that sometimes it just doesn't work. Sometimes your instrument just decides, no, this isn't happening. But astronomy in particular, it's the vagaries of the weather that you've just got to deal with. And if it's cloudy, it's cloudy. And they don't call it the land of the long white cloud for nothing,
No, although I do have to stress that this is not typical weather. I mean, we have built the observatory in one of the best observing locations in New Zealand, and very comparable to some of the best observatory sites around the world.
I guess that,
So,
the people who built the observatory probably would have thought of that. Yeah.
yeah, definitely. They did a lot of site testing before they started putting telescopes up here. It's just luck of the draw, really. So sometimes you just get bad luck.
Is that really annoying, or are you just resigned to it now at this stage of your career? It's like, yeah, you look, water off a duck's back, this is what happens. Or are you sort of, sitting there just cursing the skies every night that this happens?
I think it kind of depends on what you're observing, and the priority of it, and the how difficult it would be to get those observations at another time. So because it's summertime, I mean, we already knew the nights are going to be short. So it's, you know that you're not going to get huge amounts of data. And we've already also been very, very lucky over the winter time here in New Zealand. And I had one of my students coming down here, and we've had one of our regular observers been working really hard over the winter to do this TESS simultaneous work as well. So we've actually got quite a lot of really good data already. So it's different stars, but it's not the end of the world that we're going to miss out on this particular run.
Yeah, you win some, you lose some. That's all right. What's it like actually working there? Are there many other people around, or is it pretty quiet?
So astronomers tend to be fairly quiet. So as I say, we've got 4 working telescopes up here on the mountain. We've got one other observer who's currently stationed here. They're an observer from Japan who comes to work on the MOA telescope, which is also on the mountain here. The other 2 telescopes, one of them is 100% robotic, so it's run remotely, and the other one is kind of a shared allocation between observers and doing some outreach work. So it's currently set up in outreach mode.
Right. So how many people? I mean, I'm imagining you're in a fairly isolated place. That's the whole point, is that you don't want too many, like you don't want to put this thing in the middle of a city, right? You want it a long way away from light as much as possible. So you can't have it in an area where there's too many people around. So is it pretty isolated?
Yes and no. So we're on top of this mountain. There's a accommodation block for the astronomers to stay in. So we all stay very close. In fact, the telescope that I use is even attached to the building, which has the accommodation and so on in it. So that's basically roll out of bed and into the telescope dome.
You don't even have to get dressed. You're just you're in your dressing gown, aren't you?
Yes, walk around in your pajamas if you want to. So the mountain itself, visitors can come. It's beautiful views, so they want to come up and see those. But it is a private access, so there's kind of a charge to come up the mountain, or you can walk up for free. But there's no one else that stays on the mountain top itself apart from the astronomers.
If you're observing at night, you're sleeping during the day, right? This is shift work.
This is, yep. So I'm on night shift at the moment. It's currently just gone midnight.
So what time do you generally get up and go to bed when you're doing this?
So in the summertime, it's not too bad. We're finishing up around 5 o'clock in the morning. So into bed at 5:30, 6 o'clock in the morning.
Which would be just about when the sun's coming up anyway, isn't it?
Well, exactly, yeah. So you run until dawn.
Yeah.
And then getting up about lunchtime. In the winter, it does get a bit more tougher because the nights are really long.
Yeah.
So you do get into basically a routine where you wake up, start work, finish. So you start work about 4 or 5 o'clock in the afternoon when it starts to get dark, finish up at 7 or 8 o'clock in the morning, go to bed again.
So you do at least get, in the summer, you at least get a bit of time to enjoy the day. It's not just nighttime observation and then desperately trying to sleep through the day while all the tourists are wandering around enjoying the mountaintops. You actually get a bit of time to work, but also, have a look around this amazing environment you're in.
Yeah, there's enough time in the afternoon to go for a little walk or something like that, which is rather nice.
Cool. Oh, so are you coming to the end of your run then?
Yes, so this is last night rostered on.
Mm-hmm.
Well, hopefully we might get something later on in the night. The weather does can be quite variable. It's overcast at the moment, but hoping to have a little bit of clear sky before the end. And then that will be it for this run. We've got another observer for our program coming on over the Christmas sort of period, so we'll get a little bit more data then, hopefully, if it's clear.
So do you just sort of pack up your gear and hand over to the next people coming on? Because you've got to apply for this time on the telescopes, don't you? You can't just sort of turn up and say, right,
Yes.
It's mine for the next couple of nights. And so presumably, as soon as you leave, someone else steps in.
Yeah, so it's a shared resource. Different people come with different projects. At the moment, we're very, very lucky in our project. We get quite a lot of time. We're looking at somewhere between 1 and 2 weeks every month is allocated to this Pulsations project. It's actually, part of it's run also by the director of the observatory. So we're able to secure quite a lot of time.
Nice. It's good to know people.
But there's other projects that come on as well. Yeah. There's some really interesting work that's being done in near-Earth asteroids, hunting those down, tracking them, getting really good coordinates. Yeah, there's sort of projects that come and go that are just quite interesting. So you often meet the next astronomer coming on to the telescope and find out what their project's all about before you go, and that's quite cool.
So you're about to wind up and then head back down the mountain and back into the real world of sleeping at night and being up and about during the day. Are you heading back here to the UK anytime soon, or are you going to enjoy Christmas down in the south?
Well, since I'm down here, I thought I might as well go and see the parents
Yeah, may
and
as well.
make sure that, get a nice summer Christmas in there.
Nice. So where are you going to be spending that?
In the North Island of New Zealand in Tauranga. So it's a beautiful, beautiful little part of the world.
What's New Zealand Christmas like?
Well, it's pretty chilled out, actually. I quite like it. It's if we get a nice sunny day, it's and sitting outside. We'll have a big Christmas lunch, maybe a barbecue, maybe head off to the beach if it's really nice and warm and you want to go for a swim.
Nice. Well, look, I'm going to let you go and do your thing. Get on with your final night's viewing. May you get a little bit more in before the sun comes up.
Fingers crossed.
You've got to
Yeah.
pack it all up and head away. Yeah?
Yeah.
How's it looking? Are you hopeful?
It was looking okay at sunset, but it's sort of gotten progressively worse. But that's the beauty of weather; it can change. So we'll stay up for another few hours and see how it goes.
Well, good luck. Good luck from all of us back here at Syzygy HQ, which of course is just me. And if I don't speak to you, have a great Christmas. Have a good New Year.
Yeah, happy Christmas to you, Chris.
I'll see you sometime in 2019. God, I can't believe that's true.
Yes.
Can't believe that's actually happening.
And can you even start to imagine what amazing new astronomy is going to come out in 2019?
I know, it's going to be huge. What's the thing you're looking forward to most in 2019, astronomy-wise? Is there anything big coming up that we should be getting ourselves ready for?
That's a good question. I mean, we're going to get the first TESS publications coming out,
Yep.
which is going to be super exciting. That's going to be new planets. That's going to be new pulsating stars. It's going to be new other types of variables. That means maybe supernovae, things like that. So there's going to be a bunch of TESS stuff, which is going to come out in the next year, which I'm really looking forward to.
That's going to be fun.
Yeah.
Have we got any big eclipses and that kind of thing coming up in 2019?
I think there is one in South America.
Oh, well, we'll just
in
have to go there
2019.
then.
Yeah, I think so. That would be a good syzygy field trip.
Yeah, I reckon our funding could stretch to that. Or not. Yeah. All right. Well, we will talk to you. We'll see you in 2019.
Yes.
Have yourself a great trip. May the rest of the night go well. And yeah,
and keep
have a good holiday.
keep following our updates, because we'll keep posting some little tidbits of new things that come out over the Christmas break as well.
Yeah, not to mention gorgeous photos of mountainous New Zealand from one of us. Thanks, Emily.
No, it's okay. You can come in my suitcase next time with us.
Thanks, mate. Appreciate it. That brings us to the end of another edition of the Syzygy podcast. I'm Chris Stewart, and I've been trying not to be too jealous of the fact that Emily's down south enjoying the sunshine while I'm up here in the cold. That may have come across in the recording, I'm not entirely sure. Listen, if you want to get in touch with us on Syzygy, you can go through Twitter. We are at SyzygyPod. Get on there, check out all the latest updates, and send us a hello. You can do that through Facebook as well. Just go and search for the Syzygy podcast on Facebook, or go to facebook.com/SyzygyPod. You can also find us at syzygy.fm, our webpage. There's a contact page there. You can just send us a little note, send us a question. We might even base an entire episode around it. If it's a really good question, you never know. And listen, if you want to help us out here on the show, there's a couple of ways that you can do that, and we'd be really, really grateful if you can. Give us a review. Give us some stars and a little bit of a blurb about what you think about the show, and put that up on your podcast network of choice, whether that's Apple Podcasts or Google Podcasts or Spotify or whatever it might be. And that helps us to rise up through all the noise and helps people find us and share in the astronomical joy that is the Syzygy podcast. The other way you can help us is by telling all your friends and family. We want to grow our audience. We want to grow our family of Syzygy listeners. So telling as many people as you can really helps us out. Get some more listeners on there enjoying the show. And the last way you can help us is to go to patreon.com/SyzygyPod, where you can go and become a patron of the show by giving us $1, £1, £3, £5 a month, whatever you can afford, whatever you think it's worth. Helps us to actually do the show and make it bigger and better into 2019. Look, we've loved doing this show over the last, 10 months or so that we've been doing it? The last 26 episodes. It's been a really enjoyable first kick of the show. Hope to have you all back again in 2019 for what promises to be another absolutely cracking year of astronomy. I'm Chris Stewart, and until next time on the Syzygy podcast, when we welcome Emily back from her southern adventures, have a great holiday, enjoy the new year. We'll see you in 2019.